Hey everybody, welcome back. In this lesson, we're going to explore the concept of risk and risk management as it applies to asset management and asset management principles. If you recall, risk is one of the things that we balance in asset management. So what do we mean by risk? What does it mean to have a probability of something failing or a consequence of something failing? In this lesson, we're going to explore those topics together and see how we apply them in different asset management decisions that we make across the Air Force today. Let's dive right in. Risk is a funny topic. It's almost bottomless. It's one of those topics you can talk about all day long because it's applicable to everything we do, similar to asset management principles. So at the end of this lesson, I hope you have a good understanding of how we define risk, both using words in a definition and as a formula. Hopefully you'll be able to describe failure in the context of assets and asset management. You'll be able to list some relevant contexts for risk. You'll be able to identify attributes of the risk formula that we use commonly throughout Air Force civil engineering. Furthermore, you should be able to list some ways in which we can treat risk, and then finally, some fundamentals of how we communicate risk to different stakeholders on our installations. To meet those objectives, this is what we're going to talk about today. We're going to talk about the so what factor, then we're going to talk about how we define risk from various areas of the DoD, and then we're going to use a formula to define it as well. Then we're going to spend some time talking about risk context, defining failure, and then exploring some of those risk variables that we see so commonly in asset management. And then finally, we'll talk about how we manage risk. Risk is one of those things that's all around us. We balance it, we take it, we communicate with it. It's really foundational to who we are as engineers. So we embarked on this civil engineer transformation about 10 years ago, and we did it because we simply didn't have enough money, manpower, or time to take care of all of our assets. So the leadership at the time decided to look at asset management as a way to solve that. Everything that we weren't doing, we were taking risk in. We have a lot more things that we need to do than we have resources to take care of them. Thus, everything that does not get funded, everything that does not receive the time of our civil engineers in the shops, accepts risk. So I would argue that because we don't have enough money to take care of our stuff, we balance risk. We decide what to fund and what not to fund. We take risk. We simply don't have enough time to take care of all the work that we have on our bases. And we use risk all over the Air Force. It's not something that is just unique to engineers. It's something that maintainers use, cops use, pilots use all the time. It's one of those things that's foundational to decision making at its core. So, thus, risk is a very important aspect of asset management. And at the bottom here, you can see an excerpt from the 2016 Civil Engineer Flight Plan, published by General Green and his team. Navigating the future environment requires the use of sound asset management principles, utilizing risk-based decisions to strike a balance between capability and resources. So there we have it. Risk is important. So let's talk about risk and try to understand it. So as I said before, risk is a common language. We see it in AFIs, AFPDs, the Program Action Directive that transformed our enterprise. As I just mentioned, we saw it in the 2016 CE Flight Plan, but ultimately, like I said before, it's a common language that everyone uses to describe what they're going to do. Is this a high-risk activity? Are we going to take risk in an airframe because the avionics system is not fully mission capable? Are we taking risk in parking a C-5 on this portion of the parking apron because it's exposed to a threat? Are we vulnerable to something? So as we can see, risk is this common lexicon we can speak from. So how do we use risk for ourselves as engineers? Well, the first step is understanding what risk actually is and defining risk and defining some context. So let's explore those together. So like many of the principles of asset management, it kind of depends on who you ask for a definition for risk. If we look at ISO 31000, which is the international standard for risk management, they define it as the effect of uncertainty on objectives, sort of from a more generic organizational standpoint. If you look at the Defense Critical Infrastructure Program, or DCIP, they define it as the combination of the probability of an undesirable event occurring and the consequence of that undesirable event. If we look to the Chairman of the Joint Chiefs of Staff Joint Risk Assessment System as a framework for defining risk, you can see that the system requires combatant commands to determine the most likely scenario that would occur for each military objective by assessing probability of occurrence and consequence of failing to act. And then finally, from our own Air Force instruction on operational risk management, risk is the probability and severity of loss or adverse impact from exposure to various hazards. So, look at all these definitions. There's tons, but you can see that I've highlighted some similarities between them. Probability and consequence. Those are the two variables that we saw in each of the three common definitions in our previous slide. So, if we wanted to put this into a mathematical formula, we would then say risk sub n is a function of the probability sub n and the consequence sub n. When I say n, I'm referring to the context itself. What risk are we talking about? Are we talking about the risk of injury, the risk of impact, the risk of failure, or the risk of death? For us as asset managers, we commonly focus on the risk of failure as our most primary context. So let's explore that together. Let's explore that context idea. So as I said before, most commonly we as asset managers talk about failure as our risk context. But it's important to understand that there are other contexts that we can talk about and communicate with stakeholders across our installations. Let's take a look at this image on the right-hand side. It's a picture of a pipe leaking. What does that actually mean? If we look in the context of that one pipe, that one segment of infrastructure, yeah, it might have failed. But what is the true risk of that? The risk of that is it may impact the level of service that that system provides. So there might be a risk to the broader system. So maybe if that was the one single water main that came into your base and it started leaking, there might be a lot of risks involved in that pipe leaking. It could have cascading effect on the service that that system is designed to provide. What about interdependent missions? What is the risk of other missions on our base that rely on our infrastructure? If we allow assets to degrade and we allow things to fail, that will ultimately have an impact on our mission partners' ability to achieve their missions. So in the image below that, the pipe leaking, we have an image of a road being torn up. It's being torn up because there's been a water leak underneath the road, and thus we have to tear the road up to fix it. So we might run the risk of mission stoppage because of that. We can no longer drive down this road. Say that was a taxiway. We might have to tear the taxiway, and we would impact the wing's ability to generate sorties. What about the environmental impact of things failing? So there's a risk of environmental impact with wastewater systems. What about the public health impact? Similarly, if we allow our wastewater systems to fail, there's a risk of toxins entering our waterways. And then finally, if we allow toxins to enter our waterways, not only is there a public health impact, but we might be in violation of the Safe Drinking Water Act. So we might be fined for that failure. So it's important for us to understand that when we say an asset has failed or is failing, it has an impact beyond its own context. So the pipe failing is one thing, but what happens when the pipe fails? What happens when the runway degrades? What happens when the chiller fails? All of these are examples of assets that fail, but affect a different context of risk. So let's talk about failure for a minute. So when has an asset failed? Does a window fail when it cracks or when the vapor barrier is penetrated? Does a road fail when there's some potholes on it? At what point is that road no longer passable? There we see our pipe again. Has that system failed because there's a leak in the pipe? As we can see, failure is incredibly hard to define. It depends on the context, the purpose of that asset, and the service of that asset. So some examples for you. If we had an electrical outage, and that electrical outage caused the airfield lighting system to stop functioning, and we could not take off and land airplanes, I would say that asset has failed. It no longer functions for a certain period of time. Another example is the coolant pump in an HVAC system ceases to function. Now that facility might warm up, but it's probably still functional. And a third example is a pipe bursts in our water system and has thus failed, but the system that pipe is in can still deliver water under pressure. As you can see, it's pretty difficult for us to define unambiguously what failure actually is. So let's all agree on what failure is together, and then we'll use that as a reference point moving forward when we define probability and consequence of failure. So let's say that an asset has failed when it no longer meets the needs of the organization it supports or ceases to function as it was designed. There, that's our unambiguous definition for failure. So let's talk about probability that something will fail and the consequence if it does. When we define probability, we're talking about the chance that something will happen. Typically, we measure it in percent, but it's virtually impossible for anything to be 0% probability of failure or 100% probability of failure. But let's agree that newer assets that are in better condition are less likely to fail, and older assets that are in poor condition are more likely to fail. That's really what we're trying to get after with communicating the probability of failure. So, in asset management, typically we link probability of failure to an asset's physical condition. So what about consequence of failure? When we define consequence of failure, we mean the outcome of an event. So who cares if an asset fails? We have two factors that we want to consider when we consider consequence of failure: mission impact, or the mission dependency index, and if there are any workarounds available. So when we say the mission dependency index, I want you to remember how we calculated that to begin with, how that was originally generated. It was a function of an asset's relocatability, redundancy, and the number of interdependencies in the mission. So when we say relocatable, can we relocate the function in that facility to another facility? Redundancy, are there other facilities like it that are doing the same thing, or any backups? And then finally, the number of interdependencies, or the amount of stakeholders that that particular asset has. So you might be wondering why the degradation curve is still on your screen. And that's because this is a good time for us to talk about risk tolerance. When we talk about assets which have a high consequence of failure, we may have to attend them more frequently and earlier in their life because they are high-risk assets. They have great mission impact. And that attention might come at the cost of a lower priority facility. So thus we can say consequence of failure will commonly translate to a risk tolerance, higher for low priority assets and lower for high priority assets. If you've been in the Air Force for a minute, you know that we take risk all the time. When we decide to accept risk, we have to treat it. Fundamentally, there are 4 options for us when we take risk. The first one is to avoid it altogether. The second one is to change the probability. The third is to change the consequence. And then finally, to share or transfer the risk. Let's go over an example. So the context for this example is the risk of failure. So how do we avoid failure? Well, it's simple. We keep our assets nice. So here we have an airman doing preventive maintenance on some HVAC equipment. If we do preventive maintenance, we keep our assets in good working condition and we avoid the risk of them failing. How do we change the probability of failure? Well, here's an example of removing rubber from a runway. That lowers the probability that that asset will fail, thus lowering our risk. How do we change the consequence? That one's a little bit more complicated. Here we have a hangar. What if that hangar was in really bad shape and had to move somewhere else because ultimately we didn't have enough money to take care of repairing that hangar and adjusting the probability? We could move the functions within that facility to another facility. That would change the consequence of that particular asset. And finally, to share or transfer the risk, we often privatize some of our assets to private companies. So ultimately, if those assets fail, yeah, our mission is still on the line, but we share that risk with the private company who's managing it. So you can see here, there's at its core 4 basic treatment options for risk. So when we go out and do our corrective maintenance or our preventive maintenance, we do projects or we move stakeholders from one asset to another asset. All we're doing is treating risk. So let's have a brief discussion on where we currently use risk in asset management. Primarily, it appears in 3 different places. The first place is prioritizing projects. We see risk in the Air Force Comprehensive Asset Management Plan scoring model, which prioritizes projects in accordance with their risk, particularly their condition and their mission impact through the Mission Dependency Index and their local mission impact in their MAGCOM. We also see risk in the MILCON scoring model, and finally the environmental program. All three of these and several more use risk as the framework to make decisions for prioritizing projects. The next place we see risk is in prioritizing work, the work that we do in the CE squadrons every single day. Priority 1 is emergency, don't go home kind of work, high risk stuff. 2A helps us prevent risk. 3A through C is corrective maintenance. And if you take our Management 436 class, we'll talk about the difference between A, B, and C and how they pertain to redundant or relocatable assets. And then finally, low risk stuff, enhancement. The last place we see risk apparent is in developing investment strategies. So activity managers are charged with making recommendations about what to repair and when. So if we look at this airfield map on the right-hand side of the screen, you see a couple of red sections in bad shape. The activity manager might be looking at those as opportunities for investment that are hard-hitting projects to mitigate risk. The activity manager would also be looking at stuff that would be good to repair in the next 5 years, because those may not be in bad shape now, but by the time we get money to fund them, they might be in really bad condition. So you can see that risk appears in 3 different places in our enterprise. It's important to note that this list is not exhaustive. As I said before, we see risk every single day. We use risk to inform decisions on our built environment and our personal lives. So these 3 examples are just examples. It's not the complete list. So if we're using risk to inform decisions and make recommendations towards asset management goals, how do we communicate risk? Fundamentally, we have to be able to take our information, our data, and translate it into a language that is understood by everyone. And in order to do that, we have to do 3 things. The first thing is we have to understand what our stakeholders value. So what is important to the person that we are communicating this risk to? The next one is to understand interdependencies. So what assets or mission functions depend on the assets I or we manage? And then finally, vulnerabilities or threats. So what are the major weak points in the system which expose the mission to risk? So let's look at an example. Here we have a risk chart. This is a representative facility electrical risk profile. And you can see on the x-axis or on the horizontal axis, we have probability of failure or condition. On the y-axis, we have consequence of failure or the mission dependency index. Each one of these dots represents a facility electrical system on a representative Air Force base. So we would probably make a recommendation to invest in one of those high-risk assets. We, as asset managers, have to be able to translate what happens if the asset on the top right-hand side of this chart fails. And in order to do that, we have to have a good understanding of what our stakeholders value, what depends on that facility electrical system that that stakeholder cares about, and what vulnerabilities or threats exist to that particular asset. Communication is absolutely pivotal in this journey towards asset management. We've talked about it throughout this course, but ultimately, risk is the language that we will use to communicate the best decision at the best time. So there we have it. This is the slide you've all been waiting for, your last slide. I want you to remember that risk is all around us. We can define risk as a function of both the probability of something happening and the consequence if it occurs. The N in our risk equation is the context, and understanding that context is absolutely crucial to how we manage the risk that we take every day. When we say failure, if that's the context we're talking about, it is a difficult term to define, but our unambiguous definition is an asset has failed when it no longer meets the needs of the organization it supports or ceases to function as it was designed. Next up, probability of failure is linked to an asset's condition, and consequence of failure is linked to mission dependency. But I want you to remember the 3 aspects of mission dependency: relocatability, redundancies, and number of interdependencies. And also, when you think about consequence of failure, don't forget about any workarounds that may exist. We also talked about 4 options for risk treatment. We can either avoid the risk, we can adjust the probability, we can adjust the consequence, or we can share or transfer the risk. We saw that we're already using risk in quite a lot of different places in the CE enterprise today. We see it in project prioritization, we see it in prioritizing work, and finally, we see it in how we develop our investment strategies for the future. Finally, we talked about the 3 fundamentals of communicating risk. Don't forget, we have to understand what our stakeholders value, we have to understand what interdependencies exist in our systems and our missions, and finally, we have to understand what vulnerabilities exist to those missions. So that's what we talked about. Hopefully you've enjoyed this lesson.